Hello everyone, welcome all of you to my YouTube channel. It's Umakan Patra, PhD scholar, Department of Physics, IIT Bombay. So first of all, wish you happy Teachers Day. Today is a very special day because being a student, whatever we have been achieved till now and will achieve in future depends upon a contribution and sacrifice of a teacher. So thank you all of the teacher of the world and nation and all of my teachers personally for contributing a lot to make me. So wish you a happy Teachers Day. So first of all, there is a saying in English that a teacher can change the nation by mixing chalk and challenges. So this is an absolute line. So we should follow it because a teacher is someone who can dedicate his life for making better making better life for a student. So in this content, we will discuss some of the interesting semiconductors and apply it into the Teachers Day. So okay, so this session is going to be dedicated for all the teachers of the world. So let's start the session. So in this session, first of all, we'll discuss about what about direct band gap and indirect band gap material. So as you know, there is a two type of material semiconductor basically. This is famously known as direct and indirect band gap material. So you know, in direct band gap material, indirect band gap material, so there is a valency band, not only direct or indirect band, any band semiconducting material, there is a valency band and there is a conduction band. Okay, so this is k axis. Okay, this is our energy axis, E axis. If maxima of the valency band, this is the maxima of the valency band, this is the maxima of the valency band, and this is the minima of the conduction band. If maxima of the valency band coincide with the minima of the conduction band, then such material is known as direct band gap material. Okay, this is direct band gap material. What happens here, whenever photons having energy equal to this band gap, this is the band gap Eg of the semiconducting material. So whenever this photon having energy h mu greater than the band gap of the material fall on the valency band of the material, there is a electronic transition from valency band, that is the maximum valency band, to the minimum of the conduction band. So such material shows the very famously known as radiative transition. So this direct band gap material are used in the optoelectronic devices like LED. So best example of this direct semiconducting material are gallium arsenide, which is famously used in say LED application, gallium arsenide, indium arsenide. So these are the direct band gap material. So in other hand, for the indirect band gap material, what happens? This maxima of the valency band and minima of the conduction band. Okay, so this is the maxima of the valency band, this is the minima of the conduction band, does not coincide. Okay, it does not coincide. So whenever electron gaining energy from the photon and trying to move from valency band to conduction band, it cannot directly jump to the conduction band. First of all, it have to move into an intermediate state here. Then there is a momentum transformation between electron and between conduction band. So then electron will move to the conduction band. So these are the indirect band gap material. So the famous example of the indirect band gap material are germanium, silicon, cadmium sulfide. These are the indirect band gap material. Okay, so I hope you got the point about direct band gap material and indirect band gap material. It's the most famous thing in semiconductor physics. So I am going to apply this concept and relate it into the Teachers Day, and I would like to contribute or like to dedicate this slide for all the teachers. So here I am mentioning this, I am actually applying this concept into semiconductor physics and relating into the Teachers Day. So what happens, we all are like electrons in the valency band. Okay, so all the students are like electrons in the valency band. Okay, so we have to be free, that means we have to contribute our we have to contribute for the society by becoming knowledgeous and becoming talented. So everything is depending upon our teacher. like whenever photon having energy h mu fall on the electrons or the valency band, there is a transition of electron from the valency band to the conduction band. Similarly, we are trying to be independent and we are depending upon the teachers. Whenever teachers like photon fall on the electron like student, there is a transition of electrons or the student from the valency band to the conduction band. Okay. So now whenever we are on the conduction band, we are totally free. We can contribute for the electrical conductivity, thermal conductivity like the free electrons. So everything that we are now and will be in future, everything depends upon the contribution of the teacher. So this is a purely analysis in my frame of reference. I don't know it may be correct or incorrect, but I think we can link semiconductor into the Teachers Day in this manner. So wish you happy Teachers Day, all of you once again. So I hope we should respect our teacher and we should learn as much as possible from the teachers. Hope you got and get some interesting point through this session. Thank you so much. And also in quantum point of view, we can say that teachers are the quantum mechanical Hermitian operator with real eigenvalue, because Hermitian operator are those operators who is having a real eigenvalue. And you know, real eigenvalue is how much important in quantum mechanics, because we are always associated for measurement of energy, momentum, position, and think if we are getting real numbers, then how it is important in quantum mechanics. Similarly, teachers is important in our life. Thank you so much for watching my video. Hope you enjoy the session. Thank you so much.